Today, we're going to explore one of the most fundamental questions in all of immunology. What happens when the body's own defense system, the very thing designed to protect us, actually turns against itself? We'll trace the whole journey, from a perfectly balanced immune state all the way to a condition of chronic self-attack.
Welcome to A&P Live Studio. I'm your host, a registered nurse and an anatomy and physiology instructor. Together, we're going to connect the dots between the foundational science and the clinical realities of the complex world of autoimmunity.
So let's start with a scenario we've all seen. A patient comes in and says something just like this. This deep, unshakable exhaustion, the constant joint aches. These are classic but frustratingly vague signs of systemic inflammation. As clinicians, these are the first breadcrumbs that might lead us down a path toward a potential issue within the immune system, one where the body's defenses have gone rogue. To really understand what's going on, we're going to break it down into 6 key parts. We'll start with how a healthy immune system keeps everything in balance. Then, we'll look at how that balance gets shattered. We'll get into the nitty-gritty of the self-attack, figure out how we identify the culprits, and then talk about the strategies we use to try and restore some order. And finally, we'll take a peek into the future of autoimmune research, which is really exciting.
Okay, first things first. Before we can understand the disease, we have to understand health. And the foundation of a healthy immune system is a concept called immune tolerance. This is the amazing ability of our body's defenses to know the difference between us and them, a critical skill that keeps it from attacking our own tissues.
So, what is immune tolerance really? Well, it's not a passive state. It's an active, ongoing process. It's what ensures that while our immune cells are hunting down viruses and bacteria, they give our own healthy tissues a pass. This delicate balance is absolutely the cornerstone of immune health.
And the body maintains this tolerance with a really clever 2-layered security system. The first layer is called central tolerance. Think of this as a boot camp for immune cells in the thymus and bone marrow. Here, any new recruits that show aggression towards our own body's proteins are eliminated. But some troublemakers can slip through. And that's where the second layer, peripheral tolerance, kicks in. This system acts like a patrol out in the body, with specialized peacekeeper cells called regulatory T cells, or Tregs, that actively shut down any of those self-reactive cells that manage to escape. So now let's make that shift from normal physiology to pathophysiology, from how things should work to how they go wrong. Autoimmune diseases rarely happen because of one single thing. It's more like a multi-hit process, a perfect storm where a genetic vulnerability meets just the right environmental trigger. Which brings us to the million-dollar question, right? What causes these beautifully elegant safety checks to suddenly fail? Because the breakdown of tolerance, that's where the story of autoimmune disease really begins. And the research is pretty clear. It's almost always a 1-2 punch. First, you have a genetic predisposition. This lays the groundwork, making a person's immune system a little more trigger-happy, let's say. But that doesn't guarantee a disease. You need the second hit, an environmental trigger. This could be anything from a viral infection to a chemical exposure, something that pushes that already primed immune system over the edge into a state of self-attack.
Let's dig into those genetic factors a bit. The single biggest player is the HLA complex. You can think of these as the immune system's ID checkers. Certain versions of these HLA genes are just more likely to misread the ID of our own cells and flag them as foreign. Another huge piece of the puzzle is the X chromosome. It's packed with immune-related genes. And this gives us a major clue as to why so many autoimmune diseases are more common in women. If the normal process of switching off one of the 2 X chromosomes doesn't work right, you can end up with a double dose of immune-activating genes, which can easily break tolerance.
So once tolerance is broken, the attack is on. Now we're going to look at the specific mechanisms at the cellular and molecular level that drive this process and turn what could have been a temporary mistake into a chronic disease. The thing about an autoimmune attack is that it becomes a vicious, self-sustaining cycle. It can start with something called molecular mimicry, basically a case of mistaken identity. An immune response to a virus, for instance, accidentally cross-reacts with a protein in our own body that just happens to look similar. This initial friendly fire causes damage, which then leads to epitope spreading. As our own cells are destroyed, they expose new internal parts that the immune system has never seen before, giving it new targets to attack. All while this is happening, those peacekeeper T cells might be dwindling in number or just not working as well, which is like taking the brakes off the immune system. This allows B cells to go wild, pumping out the autoantibodies that do the direct damage. And here's where it all connects back to the patient. That systemic fatigue and low-grade fever they feel,
That's coming from a flood of pro-inflammatory cytokines like TNF-alpha and IL-6 circulating through their body. The painful swollen joints? That's caused by autoantibodies clumping together and getting stuck in the joint tissue, triggering intense local inflammation. And when you see serious organ damage, like in the kidneys, that's often from direct cell killing by cytotoxic T cells and another system called complement. Every symptom has a mechanism behind it.
So with all these vague systemic symptoms, how in the world do we actually pinpoint an autoimmune disease? Let's talk about the diagnostic approach. The real key to diagnosis is finding the fingerprints of the attack in the blood, and those are the autoantibodies. These are the misguided proteins that are targeting our own tissues. And what's absolutely fascinating is that these autoantibodies can show up in the blood years before a person feels a single symptom. This makes them an incredibly powerful tool, not just for confirming a diagnosis, but for predicting disease and, hopefully one day, intervening early. All right, once we have a diagnosis, the goal shifts. Now we need to step in and try to restore that immune balance, or homeostasis. Our treatments are all about controlling this misguided immune response and tamping down the inflammation that's causing all the damage.
How we treat these diseases has evolved so much. We started with broad immunosuppressants, things like corticosteroids. They work, but it's a bit like using a sledgehammer when you need a scalpel. They just suppress the whole immune system. Then came the era of biologics. These are much more targeted, like guided missiles that can take out a specific inflammatory molecule. And now we have what are called small molecules, like JAK inhibitors, which are so small they can actually get inside the cell and shut down the inflammation right at the source.
Let's just quickly walk through how one of these newer drugs, a JAK inhibitor, works on a molecular level. So first, an inflammatory cytokine docks onto its receptor on the outside of a cell. This acts like a key in a lock, flipping a switch that activates an enzyme called JAK on the inside of the cell. That activated JAK enzyme then kicks off a chain reaction, sending a message to the cell's nucleus to start making more inflammatory proteins. A JAK inhibitor works by getting inside the cell and physically blocking that JAK enzyme. It breaks the chain of command and stops the inflammatory signal cold. And it's so important to remember that the chronic inflammation in autoimmunity isn't just localized. It's systemic. It doesn't just damage the one primary target organ. This low-grade simmering inflammation puts stress on nearly every system in the body: the cardiovascular, nervous, renal, skeletal, endocrine systems, you name it. That's why managing autoimmunity is really about managing systemic risk, not just treating one set of symptoms. Okay, we've covered the what, the why, and the how of autoimmunity. So let's do a quick recap and then look ahead, because the future of this field is moving incredibly fast. So to put it all in a nutshell, autoimmunity starts when our body's tolerance systems fail. In someone with the right genetic background, an environmental trigger kicks things off. This sparks a self-perpetuating cycle of immune cell activation, autoantibody production, chronic inflammation, and ultimately, tissue and organ damage. Everything we've learned has led to the treatments we have today. But what's next? The new frontier isn't just about finding better ways to suppress the immune system. It's about being smarter, more proactive, and way more precise. And the future is really heading in three amazing directions. First, AI-driven disease interception. I mean, imagine your wearable device predicting an inflammatory flare-up before you even feel sick. Second, true precision medicine, where we can analyze a patient's unique molecular signature to know exactly which drug will work best for them. And third, advanced cellular therapies, where we can literally re-engineer a patient's own immune cells to hunt down and destroy only the rogue cells causing the disease. This is where we start talking about the potential for a real cure. So, that's our overview of the general pathology of autoimmunity. Please remember, this presentation is for educational purposes only, and it's not intended as medical advice. Stay patho-curious, and I'll see you next episode.